Chapter 8, Lesson 1 is solving multi-step inequalities. You can add or subtract the same quantity from both sides of an inequality and the statement will still be true. So adding or subtracting is okay. You have to be careful if you multiply or divide by a negative number. If you multiply or divide by a negative, then you must flip the inequality symbol. That means if it was a less than, you have to switch it to a greater than. If it was a greater than, you have to switch it to a less than. And the first examples ask us to solve and graph the solution set. This is 3x is greater than negative 27. So you divide both sides by 3. That cancels. And you are left with x is greater than negative 9. We have an open circle on the greater that or on the negative 9, and it's an open circle because it's a greater than. And then we want all the numbers that are bigger than negative 9, so we're going to go off to the right. Number 2, we have 2/3. To get rid of that, we need to multiply by the reciprocal. These all cancel out, and you are left with r is less than 6 times 3 is 18, divided by 2 is 9. Again, we're going to have an open circle on the 9. R is less than 9, so we want everything to the left colored in. Solving number 3. First, we're going to subtract 7 from both sides, and that becomes a negative 2x is greater than 14. Then you divide both sides by negative 2. Since we divided by a negative, we have to switch the sign. You end up with x. Switching the sign is less than, and 14 divided by negative 2 is negative 7. This is red. X is less than negative 7. So we have an open circle on negative 7 and everything to the left colored in. Number 4. This is a divided by negative 2. So to undo that, we are going to multiply both sides by negative 2. Those will cancel out, and you are left with x plus 1. Since we multiplied both sides by a negative 2, we have to switch that sign around. 3 times negative 2 is negative 6. Notice I switched the sign. And then when we subtract 1 from both sides, that becomes x is greater than or equal to negative 7. This time we're going to have a closed circle on the negative 7 because it's greater than or equal to. And then the numbers that are greater than go in this direction. Number 5, we're going to distribute. This becomes a negative 9. Negative times a negative is plus 3x is greater than 16. From there, we will add 9 to both sides, and you have 3x is greater than 25. From there, you need to divide both sides by 3, and you have x is greater than 25 thirds, and 25 over 3 is 8.3 repeating. So an open circle on 8.3 repeating, and then all of the numbers that are greater than that. Number 6, I'm going to change these to decimals. 0.8x plus 0.5 is greater than or equal to 0.6. From there, we subtract 0.5 from both sides, and that becomes 0.8x is greater than or equal to 0.1. And if we divide both sides by 0.8, you end up with x is greater than or equal to 1/8. And if you divide that, that is 0.125. So we're going to have a closed circle here on 0.125 or 1/8, and we want everything greater than that, so everything over there colored in. Number 7, from here we subtract 3x from both sides, and that becomes negative 2x is less than 8. When you divide both sides by negative, dividing by the negative, you have to switch your sign, and that becomes x is greater than negative 4. And if you guys don't mind, I'm going to skip the graphing on the rest of these. Number 8, from here we will subtract 3.5x from both sides, and that becomes 2.5x minus 1 is greater than or equal to 4. From there we add 1 to both sides, and that becomes 2.5x is greater than or equal to 5. And when you divide both sides by 2.5, that becomes x is greater than or equal to 2. I am going to graph this one a second. X is greater than or equal to 2. You're going to have a closed circle because you have the equal to, and then everything to the right colored in. Number 9, when you distribute, that becomes 2k minus 6. Over here, 6 minus 3 is 3 plus 3k. From there, you subtract 2k from both sides, and that becomes negative 6 is greater than 3 plus k. And when you subtract 3 from both sides, you have negative 9 is greater than k. Number 10, I'm going to change this 1/4 to 2.25. Just change that fraction to a decimal. And that becomes 0.25p minus 2.5 is greater than 6 minus 4p. From there, we add 4p to both sides, and that becomes 4.25p minus 2.5 is greater than 6. And then when we add 2.5 to both sides, we're running out of room here, 4.25p is greater than 8.5. And when you divide both sides by 4.25, you end up with p is greater than 2. Number 11, when we distribute, that becomes 6y minus 4 minus 4. It's greater than or equal to 6y plus 21. These two get combined, and that becomes 6y minus 8 is greater than or equal to 6y plus 21. When you subtract 6y from both sides, you have negative 8 is greater than or equal to 21. It's not a true statement. It will never be a true statement. So here there are no solutions. Number 12, when you distribute, that becomes x minus 3.5 is less than or equal to 10 plus x. From there, you subtract x from both sides, and you have negative 3.5 is less than or equal to 10. That is a true statement. It will always be a true statement. So your solution here is all reals. And if you're in Mrs. Clausen's or Mrs. Twig's class, I don't think you had these last four. Writing an inequality, 5 is our border, and these numbers go to the right, so they are bigger than 5. So that will be written x is greater than or equal to 5. Or you could also write 5 is less than or equal to the numbers. It's kind of hard to tell. I think this is an open circle, so I'm going to make it a big open circle. Those numbers right there, they're to the left, so those are less than negative 5. Again, I think this is an open circle. These numbers here are to the right of 1, so those numbers are greater than 1, or you can say 1 is smaller than the numbers. And then this one, I think again this is an open circle, and these numbers are to the right of 1. That's the same graph, isn't it? N is greater than 1, or 1 is less than n.